all. This is Dr. Sivaji. We are going to discuss the subject that is compiler design. In this, we have type expressions. Whether the type expressions are to be same or not can be verified by using an equivalent concept of equivalence. So let us see that how this concept of structural equivalence can be verified with the help of this type expression. So we know that type expressions are to be calculated with the help of basic type or structural type. With the help of a basic type or structural type. Now these are the various basic types and structural types which we were used in the notations, and we are also applied various constructor notations such as arrays, products, records, and then pointers, functions. Now, what are the various type of expressions we have seen with an examples in the previous video? That is, whether the equivalence of the expressions can be done with the help of two notations. One is structural equivalence, another one is name equivalence. So in structural equivalence, the two expressions of basic type, that is constructors, are also used, and we are going to verify whether these are all structurally equivalent or not based on the basic type as well as the constructor which are applied for that notation. If these types equivalent, that means this type constructor or basic type, then we can say that it is a structurally equivalent. Then we can say that it is a structurally equivalent. If and only if they are identical. If and only if they are identical. That is clearly specified by applying an example with the consideration of integer value, and we have taken the basic type. This is the basic type as integer, and the corresponding type is also integer, is equivalent to integer, then we can say it is structurally equivalent. Suppose if the type is constructor type or structural type. If structural type is a pointer of integer, then if it is a matched to the corresponding same constructor type, then these two are said to be structurally equivalent. So, a type expression integer is equivalent only to the integer if and only if they are both belongs to the basic type. And second one is pointer of integer. That means it is a constructor type where it is only pointing to pointer of integer. That in that case both of them of same type, then these are formed by applying the same constructor pointer to an equivalent type. So then only we can say that it is a structurally equivalent. And we have seen the algorithm of the structural equivalent, how these two cases can be done. If S is one structural type expression and T is another type expression, this algorithm is very important. Two type expressions are said to be structurally equivalent or not can be verified by applying a condition whether they are belongs to the same basic type or type or not can be passed as a condition. If these two values can be passed If at all, if they are of type, then it displays the corresponding structure, else it returns not structural equivalent. When you run this algorithm, it verifies whether they are belongs to an array, whether it belongs to product, pointer type, function type. Then it specifies the corresponding structure. Then the equivalence can also be verified with the help of another notation. The tree diagram structure also can be verified with the help of. And second one is a name equivalence of type expressions. These type expressions can also be verified by using structural equivalent one case, another one is name equivalence also. So how this can be verified namely? So generally we can represent some of the languages such as Pascal, Fortran and other programming languages where the types are given with the different names and they are declared with the notations as per the syntax structure of the programs. So here for example link is a pointer. So this is a pointer cell. Pointer cell. So that is determined as upward pointer cell. That is equivalent. Now there is one more, that is next is defined with variable, last is defined with one more variable link. Then P, Q are they are defined with the pointer to cell. P, Q are defined with the pointer to cell. Now here the variables, if you consider next is one variable, last is one variable, P is one variable, Q is one variable, R. So these variables are declared with the different declarations of the types. So that is they have their own types. Then we have to verify whether they are following with the same types, identical types or not. Whether they are following, we are going to determine whether these following the same types or not. If the type expressions have the names and names appears in the type expression, that means name we are going to verify here to obtain whether that the variables were really compatible with the corresponding notations and declared with the types, then we can say that they are name equivalents of the corresponding type expressions. Else it is not. So in that way, type expressions have some names and these names are appeared in the type expression and we are going to verify whether both are same. If they are same, then we are going to define. For example, cell, it is the name of the type expression. Here, one type or name of the type expression is cell. Then pointer of cell is a type expression. So what is the type expression here? Pointer of cell. And what is the name? Cell is the name. So in that way we are going to determine this type expression. Let us see this one with an example also. So here type expressions we are going to identify with this one. So with the variables corresponding type expression. So the type expression pointer of cell. Cell is what is the name of the type expression? Cell. And pointer to cell is the type expression. So name of the type expression and type expression can be individually verified and compared with other variable, that is link, the type expression and the pointer to cell, like that. And the name equivalences verifies each type name. So here previously we have seen the name for each and every variable. So if they are distinct type, so then that is equivalent can be verified. Name equivalent will be verified with the help of these names, name types. So under structural equivalence, if previously you have seen structural equivalence, if the names are replaced by the type expression. So here in the structural equivalence we have verified with the type expression. So the type expressions are replaced with the names, then we can say that it is a name equivalence. Previously type expressions, whether two type. Here also name or name type can be verified, but here the type is name, but that one of the type expression which is equivalent to that one. So these two are equivalent structurally whenever the type expressions with the names have been substituted out. So here in this case, names instead of type expressions. Instead of type expressions, we are going to use names. That names of type expressions are matched, then we can say that it is a name equivalence of type expression. So here, name equivalence can be verified with an example. So here we have seen one example, we have taken one example. What is the type expression that might be associated with the variables in the given declarations? So here next is one variable, last is one variable, P is one variable, key is one variable, R is another variable. So what is the type expression here for the next link? For type expression, link, last. And what is the type of expression for this variable P? It is a pointer of cell. What is the type expression for variable? Pointer of cell. What is the type expression for variable? Pointer of cell. Now for each of the variables, we know the type expressions, and this type expression have each of the variable has the same name or not. So here if you consider the variables P, Q, R, they are having the type expression is same type expression. Same all P, Q, R have same type expression. Same type expression. That's why they are equivalent. Next and last, they are also having the same type expression. The same type expression, which of the variables holds in the given. So P is one variable which holds, Q is one variable, QR is one variable holds. So they are having expression is pointer to cell. This one also pointer to cell, R also pointer of cell. So in all these cases, these are equivalent. So this might say that this P equal to Q equal to R. Structural, that is same type expression. And these declarations next equal to last have same type expressions. But if you compare P with, for example, if you compare a P with any other associated next. So what is the type expression for P? It is a pointer of cell. Type expression for P is pointer of cell. And what is for the next? Here link. So this type expression need not match. P is of type expression is one thing, next is another thing. So both are not matched. So that's why P not equal to next. And if you compare with any other type expression, for example, P and last. So what is the P? P is pointer of cell. P is type expression is pointer of cell. What is last? Last is pointer expression is type expression is link. So whether these two type expressions are equivalent or not, right? This is one different type expression, this is one different type expression. So both are not equivalent, so that's why P not equal to last. P not equal to last. So whereas R, we can also write R, can we compare with any other? R is equivalent to next. Whether both are equivalent type expressions, name equivalence. No, why? Because the type expression name of that corresponding variable R is pointer of cell, and whereas next it is link. So both are not equivalent. So like that, the equivalence, name equivalence can be verified for each of the type expressions, whether they are following the same name type expression or not. So that name equivalence is specifying that it verifies each type name, whether they both type equivalent or not can be verified. That means previously in structural equivalence we are going to verify the type expressions. Instead of type expression here, the names of the type expressions can be verified. So here both are different and some of them are same. So that is equivalent can be verified with these three cases. That is P equal to Q equal to R. These two are equal. That's why it is next equal to last. So next variable have the same type expression same as the last. Whereas the type expression which belongs to the variable P same as type expression which belongs to the variable Q and type expression which belongs to the variable R are same. So that's why we can say that these two. Whereas the type expression for P with any other next and last, these are all not equal. And also we can see that structural equivalent of Q with next and last, these are also not equivalent. Why? Because Q is of type pointer of cell, next is of type link type. So list Q also. Similarly for R, which is not equal to next, R is not equal to last. Why? Because their type expressions are different. If they are different, then we verify whether it is matching or not. If not, name they are not name equivalents. If match, then we can say that. So in the three cases, these are all name equivalent and these two are not name equivalent. These two are not name equivalent. Next. Name equivalence. Under name equivalence variables, that's what next last have the same type. That means same type and that means type expression is same. Type expression is same. That is here link type. Next also link type. So that's why the type associated for the corresponding variables next and last have the same type expressions. That's why it is defined as next equal to last. And the variables P, Q, R, they are also having the same type. That means type expression is same. But P and next do not. Since associated type expressions are different. So next and P, if you compare the total no, P, Q, R, they are equivalent. But next not equal to P, last not equal to P, or next not equal to Q, or last not equal to P. So this that is next and last which is not equal to P or Q. Why? Because here last belongs to the link pointer. So that's why here it is a type expression is link, and according to the given declaration, Q is pointer of cell. That means this is one type expression, this is another type expression. Both are not matched. That means here names of type expression both does not match. Names does not match to the corresponding expressions. Then we can say that it is not structured name equivalent. If the variables which belongs to the type expression, then only we can say that it is stem. So all we can under structural equivalence we can say that 5 variables have same type or not. Under structural equivalence, all the 5 variables have the same type because link is a name of the type expression. So what is the link here? Pointer of cell. So that's why it is it. Now we'll see another example whether these are all structural equivalent, name equivalent with one example. That is here. If you observe here the type vector. What is the vector type? It is array. Vector is of array. Another type is weight. Another type is weight. This is what type? It is array. Type expression is array. And x, y. Another variables x, y vector. And z weight. So x, y vector and array is z is weight type. Now, okay, what are the variables which holds name equivalents, and what are the things that comes under structural equivalents? According to the structural equivalents, according to the name equivalents and structural equivalents, we will verify once again. So here, name equivalents. What is the type expression for the corresponding variable? Suppose x. What is the type expression? So here the variable x, which holds the vector is of type array. So y is a vector that what is the type? It is array. So this is array. It is also array. So both are same type. But z, if you consider z is weight. This weight is array type. Z is weight array type. But here the type expressions are name. Name is different. So here vector is one type. This both belongs to vector. And this one belongs to weight type. So this is also array. But this array is weight type. So this name is different. This name is different. This type expression array with vector type. This is y variable array which holds values, but it is also a vector type. So z is also a array of that is vector, that is weight, but it is not vector. It is a weight type. So this x, y have the same name. That means name equivalent. Name equivalents x and y both are equal. But name equivalents x equal to y, it is holds good. But x not equal to z, y not equal to z. These two holds good for the case of name. Why? Because x is of type vector and z is of type weight. So vector is different, weight is different. So that's why these two are not equal, x and z, and y and z also not equal. For x and y together, they are having the same types. So name equivalents are x and y. Whereas if you come to the structural equivalents, here x and y have this same type. That means here we are going to verify the type expression. Type expression says that what is the variable which holds the corresponding type. That means what is the structure? Here x is of what type structure? Array type structure. And y is of type what structure? Array type structure. Z is of structure? Array type. So the structure is same. So that's why it is called as structural equivalence. But if you come to the name, what is the array structure holds the type? That is vector type. Y holds vector type. Whereas Z holds not vector type, it is weight type. So that's why under structural name equivalent, these three variables does not equal. That means x equal to y but not equal to z. Whereas structural equivalent, here x, y, z, these three variables which holds the same structure, array structure. And then that's why we can say that some of the type expression, what is the value it is holding, whether it belongs to the same type expression or same type or same name. Verification with the name equivalence can be verified with the name and basic type structure, and whether it follows the same structure or not by applying this structural equivalence. So strictly checking this, and then we can conclude that yes, it is a x and y are the both name equivalent, but z is not name equivalent with the x and y. Whereas variables x, y, z both follows the same structure, so that's why they are structural equivalent. And if you take the name equivalence of some of the type expressions in this example, what is the link type pointer to cell? Another variable NP pointer cell, NQR pointer to cell. Here variable next is defined link type, last link type, P, NP, P, NQR, R, NQR. That means here link this pointer to cell. It is defined with pointer to cell defined with the link NP, NQR. Whereas a link is defined with that is next and last. Whereas PQR, P is NP. That means P is a pointer to cell. Pointer to cell, whether it is P. NQR, it is also pointer to cell. NQR, that is QR, that is also pointer to cell. So what is the here? NQR, it is a pointer to cell. So that's why we can organize a tree expression structure, whether this belongs to the same name, that means type expression, this is equivalent or. So let us see how this, what are the variables which are belongs to the name equivalence, structural equivalence. So name equivalence of type expressions, we are going to construct a graph notation also. Every time a constructor is to be defined, and with that a node creation, and any new type name occurs or not, see if any possibility, then a leaf is to be created with this one. You can first create with the construct type as a tree structure as a root node, then verify any new type occurs, leaf to be created, and then keep track of all the type expression which names referring. So like that we are going to construct the structure. So here, if at all, if any two type expressions, that means if they follow representing the same node, that means previously we have seen, that means a pointer to cell, so that is referring the same node or not. So link is referring pointer to NPs. So if at all, if that structure like that referring the same type expressions, two type expressions equivalent, if they are referring the same node in the type graph notation, then that expressions are to be represented with it as separate declaration as dotted lines, which shows the association between the variables and the nodes in the type graph. That means we are given the line, instead of line we are going to write a dotted line representing there should be association of between variables and nodes in the graph. And type name has three parents. Type name cell, which has three parents, all labeled with pointer. So here type name pointers to cell. So this type name cell has three parents. That means it belongs to the some node in the graph. If at all, if you write a relationship, that then we will get that relationship between parent and child. An equal sign appears between the type name link and node in the type graphs. We are going to write a representation of equal sign also, where type. So we'll see the diagram representation, pictorial representation here. Link is a point, that is pointer of cell. Link is also pointer also. So here this is a link and this is pointer of cell. So link equal to pointer and pointer of cell. So this is link, which is the pointer of cell, and this is the pointer of cell. And the next and last. So the variable declared here, next and last. So these two variables declared as link. So that is next and last, that is to be declared as next and last. Whereas PQR, if you consider PQR, so these are all referred as NP. What is NP? NP is pointer to cell. NQR, pointer to cell. NQR pointer to cell. So here next link. Link means pointer to cell. Link here pointer to cell. So like that we are going to define the as a tree structure pointer of cell PQR. So pointer of cell P. What is P? Point NP. NP is what? Pointer of cell. Q NQR. It is pointer of cell. R NQR pointer of cell. So we are going to describe that is P pointer of cell. Pointer of cell, or we can also write arrowhead pointer this like this, pointer of cell. What is Q? Also pointer cell. What is R? Pointer cell. So the same expression here, P NP. What is NP here? NP is pointer cell. So that is to be written as NP is equal to pointer to cell. So that is P is pointer cell. So in that way we are going to declare as a type graph notation pointer to cell. So this is the structure is to be represented where PQR with the pointer of cell. So that means there will be an association between variables and nodes. So what are the variables here? Next, last, P, Q and R. So and the nodes are to be represented in the type graph. So we are going to write as dashed lines. Here the association between variable and nodes. We are going to represent the dotted lines, association between variables and nodes as dotted lines. So that some as parent and child. So here three parents are labeled as pointer and name is type cell. So pointer to cell is to be represented name and three variables represented as parents. So this is the P as parent, the Q and R. These are the three parents of that structure. And in this way we can define a program structure. We can say that two type expressions are equivalent if they are represented by the same node in the type graph. If they are represented in the same node in the type graph, then we can say that this if the node labeled is same as that node which is available, then the type expression of that particular node is same as the type expression of the previous node. Then we are going to verify if both are same. Then we can say in the type graph, then we can say that they are type expressions are equivalent, else they are not equivalent. So like that we are going to verify this equivalence of the name, equivalence of the type expressions. So here the type expressions can be verified link NP equal to NQR equivalent to link. That means they are having the same type expression, pointer to cell. And the next equal to last. So they are next equal to last. So they are also having the same type expression. That means here the type expressions of this next and last equivalent. Then we can say that it is a name equivalence of the two expressions. These are name equivalent. And the P and NP and QR, these are also name. Whereas P equal to Q equal to R. These are also name equivalent. Yes. Then we can say that name equivalent. That means here what is P referent? NP. NP is pointer to cell. So the type equivalence name is equal. Whereas if it comes to the, for example, next it is of type link. Whereas NP next link type. Link is pointer to cell. So it is equivalent to R. No, it is not equivalent to R. NQR is point cell. Next is a link. Link is point. So like that we are going to verify whether they have matched the same type expression or not. If that name equivalence observe the two type expressions, then we can say that it is type. So in this example also we have seen how the both are x and y, they are having equivalence with the type expressions of array type, that is vector, And Z is also of array type, but it is a different type, that is weight type. So that's why they are not structure name equivalent with X and Y. Z is not the name. Whereas X and Y together, they are name equivalent. Why? Because they are of type expression, same type notation. But even though it is an array, but type defined is vector type, so they are name equivalent. But if it comes to the structural equivalent notation, X is of type array and Y, Z, all are belongs to the. So here we don't see the name, but we have to see the structure. So here structure is array. So that's why we can say that all the three variables which are belongs to the same structure. So that's why they are structural equivalent. So like this, we are going to verify the cases like whether both the expressions of matching the same type expressions with then we can say that it is a structural equivalence, else we can say that it is a name equivalent. So by using the graph notation also, you can easily identify that the graph picture notation also. We can maintain the parent child relationship with the corresponding dashed lines, that means indicating the association between the parent and the child relationship. Like that, we are going to draw a notation where this equivalence verifies, and then based on that one also we can say that whether it is structurally equivalent and name equivalent also can be verified. So we have seen an algorithm also how the structural equivalence takes place for the two type expressions. So basically the expressions are of two types: basic type first, another one is structural type. If basic types are same type or other array type, constructor type, if both are matched, then that is to be considered with the corresponding structural equivalent. Else, the names can be verified. If at all, if there are possibility of the names, then we can say that name equivalent. So in this way, we have seen with verified with various examples also for both the equivalences, structural equivalence and as well as name equivalence also. So with this concept, we are closing this session. Now the next topic we will come with a new topic, that is how the expressions can be evolved with this one. So all the contents which we discussed in this session can be obtained from the book, that is Compilers, Principles, Techniques and Tales, that is Alfred, City and Whitman. And thank you once all of you. Once again, thank you. We'll meet with the next topic in the next coming session. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.